Hello and welcome back to Cherry's online classes. When do you say an object is moving? What is distance and what is displacement? What are the differences between distance and displacement? These are the topics we are going to learn today. Okay? Now, look at these two. You know, this is scale and this is pen. Now, I am going to keep this scale stationary. That means the scale is not moving. And now see, I am moving the pen. So, with reference to this scale, this pen is moving. Why do we say with reference to the scale? That we'll see. Here you see, I am keeping them together and moving them together. Now see, is the pen moving with reference to the scale? No, but they are moving with reference to me. Understood the difference? See, I am sitting on a chair here. If I ask you, am I moving? Your answer will be no. I'm not moving, you say. We are all living on the earth. And you know that the earth is moving around the sun. Now you see, if I ask you the question, am I moving with reference to the sun? What is the answer? Yes. The earth is moving, so I am also moving. So reference point is very important when you define motion. Is it clear? When do you say an object is moving? When the object changes its position about a reference point with respect to time. Now the reference point I'll explain with an example. Now I'll explain the term reference point and motion with an example. Here you can see the bus stop and a girl standing there, and you can see the school van coming towards it. Okay. Now with reference to the bus stop, the van is moving. We have taken the bus stop as a reference point. So the girl standing at the bus stop finds the van to be moving. There's no doubt about it, isn't it? Now you see, suppose you take the driver in the van as a reference point. Now, are the children moving with reference to the driver? No, they're all seated on their seats. So, you can say children are not moving with reference to the driver. Is that clear? We have taken the driver as a reference point. See, there's no change in the distance between the driver and the children. You have to see the reference point and see if there is any change in the position to say whether they are in motion. That's why we take the reference point to define motion. Now we'll see the term distance. How is it defined? It is the total length of the path travelled by an object irrespective of the direction. What is it? It is the total length of the path travelled. If an object is moving, you have to take the length of the path travelled by that object. You don't have to see the direction for that. So we say irrespective of the direction. And we express it in meters or kilometers. Its unit is meters in SI system. Okay. Now we'll see this girl is walking towards the west direction 20 meters. Okay, the distance covered is 20 meters. Which is the final position? It's marked there, and the initial position at the house. So the distance between the initial position and the final position is 20 meters. Is it clear? Now, she is returning back to her house. So, what is the total distance now? 20 meters in the west direction and 20 meters in the east direction. So, total is 20 plus 20, 40 meters. That's the distance. Now we are going to learn what is displacement. Displacement is different from distance. Okay. Now how is it different? Here you find that displacement is the shortest distance from the initial position to the final position, and along with the direction you have to mention it. So what is it? It is the shortest distance from the initial position to the final position along with the direction. For distance you don't have to mention direction, but for displacement direction is also mentioned. It is necessary to mention the direction along with the magnitude. Okay. Now here you can also say displacement is nothing but the change in position of an object measuring from the starting position to the final position. Always you have to measure from the starting to the final. And this is also expressed in meters in SI system. The unit is meters, same as distance. Okay. Now I'll explain the term displacement with an example. Here you can see the house of a girl who goes to the shop, which is at a distance of 2 kilometers from her house. Okay. She is going to the shop to buy something from there, and then from there she is going to the park, which is at a distance of 3 kilometers. So, how much is the total distance she has covered? It is 2 kilometers plus 3 kilometers. That is the total distance she has covered to go from her house to the park. Okay? But what is the displacement? What was her initial position? House was the initial position. She started walking from the house. So you have to take the house to be the initial position. Which is the final position? That is a park. She has reached the park. Isn't it? So you have to look at the initial position and the final position only to find the displacement. Is that clear? You don't have to see the path she has followed. So, from the initial to the final, what is the distance you have to see? It is 4 kilometers to the east. So, actually the displacement is only 4 kilometers towards east. That is the displacement. But the distance you found to be 2 plus 3, 5 kilometers, which is more than the displacement. So, displacement and distance may not be equal in magnitude. So, for expressing the displacement, you have to find the magnitude as well as you have to express the direction. Only when you express the direction, it will be meaningful, because you are seeing from the initial position to the final position what is a change in position. Is it clear? So, change in position from the initial point to the final point you have to take. And direction is also mentioned along with that. You don't have to see the path. It is the shortest distance that you take to find the displacement. Now you can see a square path. And the initial point here is marked from where the car is going to start moving. Now look, it goes along the path and then comes back to the initial point. So what is the total distance the car has travelled? It is the sum of all the 4 sides of the square, or the perimeter you can say. Isn't it? But what is the displacement here? Initial point is same as the final point. So is there any change in position? No. So you can say the displacement is 0. displacement is equal to 0 when the initial point is same as the final point. There is no change in position here. Okay? Now we'll take one more example to show the displacement to be 0. Here you can see a boy standing with a ball. He's going to throw it up to a height of 2 meters and catch it back. What will be the displacement of the ball? To calculate that, first you have to see the initial point. Okay? That is his hand. Okay? Now he throws it up and catches it back. What will be the displacement? When the initial point is same as the final point, displacement will be 0. Is that clear? Displacement is equal to 0 as the initial point is same as the final point. But what is the total distance? Distance covered by the ball will be equal to 2 meters up and 2 meters down. Total is 4 meters. Now we are going to see how displacement can be negative. Displacement can be negative also. Look at this example. Here the boy standing with the ball. He is going to throw it up to a height of 2 meters, but he is not going to catch it. The ball falls down. Okay? It falls on the ground. Now how are you going to calculate the displacement? The question is to find the displacement if the ball thrown up to a height of 2 meters falls on the ground. Okay? Which is the initial point here? It is a hand. The boy's hand is the initial point. Okay? And the distance the ball goes up is 2 meters. But from the hand to the ground, it is 1 meter. From the hand to the ground, it is 1 meter. It is given. In the question, it is given as 1 meter. Is that clear? So, the initial point is his hand. From the initial point, the ball goes up and it is falling onto the ground. What is the total displacement? How do you calculate? From his hand, from the initial point, it goes up to a height of 2 meters and comes back 2 meters plus 1 meter. Coming back is 2 meters plus 1 meter down. Isn't it? So, the final point is the ground. So, from the initial to the final is what you have to see for the displacement. You don't have to see the path. You just see the change in position from the initial point to the final point. How do you calculate displacement? From the initial point to the final point you have to measure. So how much is it? It is just 1 meter. Okay? But you see, it is written as minus 1 meter because the direction has changed. Initially, the ball was moving in the upward direction, but final point is in the opposite direction, just the opposite direction. So the initial direction and the final direction both are different. So when the direction changes or when it returns back, you take the displacement to be negative. Is that clear? 1 meter is calculated by taking the measurement from initial to the final point, and minus sign you have put for the change in direction. Is that clear? So you say the displacement is minus 1 meter in the downward direction. It is. Okay? Is that clear? Now we'll see the difference between distance and displacement. Suppose you are standing at the gate of the school and your teacher is coming on the way and she asks you, where's your house? You may say, my house is at a distance of 2 kilometers from here or 4 kilometers from here. But if you just say it is at a distance of 4 kilometers from here, can the teacher make out in which direction she has to go to find your house? It's not possible. So you have to mention the direction along with the magnitude 4 kilometers. So that you call as displacement. Along with the distance, if you give the direction, it becomes displacement. Okay? But for displacement, you take the shortest distance from the starting point to the final point. But for distance, it is the length of the path along which you move. So, you have understood the difference between distance and displacement. Now, we'll see some quantities, physical quantities, are expressed along with the direction. For example, force. If you say I've applied 1 Newton force, unless you mention the direction, you won't be able to find out in which direction force is applied. So, always when you talk about force, direction is also given along with the magnitude. So, such physical quantities where you express both magnitude and direction are called vector quantities. Whereas a physical quantity like distance, volume, area, you don't mention direction, you mention only the magnitude. Such physical quantities are called scalar quantities. Okay? Now we'll see how to define scalar quantities and vector quantities. Okay? A physical quantity which has only magnitude but has no specific direction is called a scalar quantity. And what about vector quantity? It has magnitude as well as direction, isn't it? So which are the quantities that have only magnitude and no direction? Examples: length, area, volume, mass, time, energy, and so on. We do not express direction along with the magnitudes of these quantities. Okay? So they are scalar quantities. Now, a physical quantity having magnitude as well as specific direction is called a vector quantity. Now, examples: displacement. You have seen that displacement is expressed with the direction. Okay, direction is very important there. Velocity, force, weight, all these are having directions. So they are all vector quantities. Is it clear? Now we'll see the difference between distance and displacement. What is the first point? Distance is the length of the actual path traveled by the object in a certain time. You have to take the path, length of the path. Okay? But for the displacement, it is the shortest path traveled by an object in certain time. It is from the initial to the final position. Okay? Now, next point is distance. It depends on the path followed by the object, where for displacement does not depend on the path followed by the object. Distance is always positive, but displacement can be positive, negative, or zero. You have seen the examples for all these where displacement becomes positive, negative, and zero. Now, distance can be more than or equal to the magnitude of displacement. Distance is usually more than or equal to the magnitude of the displacement. But for displacement, its magnitude can be less than or equal to the distance. When do you find the distance and displacement to be equal? When the object is moving along a straight line. in one direction, moving along a straight line in one direction. You find that magnitude of distance and displacement are equal. Okay. The next one, distance is scalar quantity, whereas displacement is vector quantity. Now the main points to remember. First point is that when the object moves in a straight line, the distance is equal to displacement in magnitude when the direction is not changing. Okay. Now the next point, displacement is equal to 0 when the initial point and the final point are the same.